So the first question is just an arrow pushing question. Now, one of the things that's helpful in these questions is that we know what the bonding changes are, and all we have to do is figure out what caused the curly arrows to change. So, what do? Well, one of the things, if we look at this first one, we can see that we have a hydroxide and we have a ketone, and that ketone has some alpha hydrogens, and we see that we have some bonding changes. We can see that our hydroxide has picked up a proton and become water. So this is a reaction. That's why we have the reaction arrow. But it's helpful if we put in the hydrogens, at least for the first two. We see the same thing in the second reaction. So once we put the hydrogens in, now it becomes a little easier. And we see that we have hydroxide over here and water over here. So it has to pick up a proton. And we're going to form a carbon-carbon double bond. So we're going to first pick off that proton. Then the electrons that are in this carbon-hydrogen bond reorganize to form that carbon-carbon double bond. And then at the same time, we can't have a pentacoordinate carbon there, so we have to promote the electrons that are in the pi bond and the between carbon and oxygen up onto oxygen. And we see it over there. So all we're doing with these curly arrows is showing the electron movements or changes that have to occur to explain the bonding changes that have to occur. We have an acid-base reaction, but we're pulling off this proton, and then we get a bunch of bonds change that follows it. And we can do the same thing for the rest of these reactions. We pull off that proton, and the electrons that are in that carbon-hydrogen bond have to go somewhere. And in this case, they just go right onto that carbon. And there we see the anion. And kind of the same thing, what's going on here. We're going to form a bond between this carbon and this carbon. It's these electrons that are going to do it. And when those electrons reorganize to form that bond, they leave this carbon electron deficient and is positively charged. And finally, we can do that. We take a lone pair of electrons on oxygen, we throw them there to form an oxygen carbon double bond, and at the same time, this is our tetrahedral intermediate, and it kicks off an ethoxide. So we get our final product. The last reaction is the only one that's not a reaction. In fact, it's just resonance, because all we're changing here are bonds, no atoms are moving. And this one's quite simple. We just move our carbon-carbon double bond from one side to the other, and we get resonance.